Good afternoon, everyone. Good afternoon. Hope all is well. Hope everyone's doing great.
Hello.
All right, TCC's internet face or interface, whatever you want to call it, would not let me connect. So finally got through. Now we are cooking. All right, let's see. Looking at 162. Get that last. Okay, here's where we are today, 6-3. All right, so I hope everybody is doing all right. Had a great weekend. And ready to get rolling with some good old trig. So we have double angle, power reducing, and half angle formulas that we're going to talk about today. All right, scrolling up a little so we can get all of them in there. All right, so we're looking at sine of 2 theta. It's going to be 2 sine theta cosine theta. Cosine of 2 theta, cosine squared theta minus sine squared theta. And then tan of 2 theta is equal to 2 tan theta over 1 minus tan squared theta.
Could you go up for like 1 second?
No, just playing. You just want the title.
Yeah, I forgot to do it.
It's okay. It's all good.
All right.
Okay, so just to make sure, the homework is due this Sunday?
I gotta look and see what's up there. Whatever I told you guys, I have to go and check it. So I'll check that date before we close out.
The 17th, you've said. So Thursday.
Okay, thank you, sir. Yeah, I got multiple classes, and once I put that due date out there, I don't have to remember it no more. So yeah, thanks for that. So yep, the 17th is what we got in math lab. But whatever math lab reflects, that's what we initially talked about. Now, once again, if you guys need extensions or stuff like that, talk to me individually, and then we'll go from there. Are we done with that title? Want to make sure we're good. Everybody good?
Yeah.
Okay. Thank you. So give you guys a chance to copy out all of those formulas, and then we'll use them accordingly. Let's scroll up a little. All right, so we have if sine theta is equal to 5 over 13 and theta lies in quadrant 2, find the exact value of each. So we have some down there. A, B, and C. So everybody done with the purple? Okay, there you go. Sine of 2 theta, cosine of 2 theta, then tan of 2 theta. Use a relationship that we just established and the given information to figure out those. All right, so let's go ahead and try it out. So first of all, we want to find the missing piece. We have sine theta of 5, or sine of theta is equal to 5/13. So we want to figure out what is x. We know that sine is y. over R. All right, and since it's positive, and we know R is always positive, so we have a positive 5 over a positive R, Y is positive 5. So we have to solve for X by plugging it into our distance formula. So 5 squared and 13 squared is 25 and 169. So subtract 25 from both sides, that'll give us X squared equal to 144. Take the square root of both sides, that'll give us plus or minus 12. And then remember, theta is in quadrant 2. It has to be, so X has to be negative. That means 12, it'll be negative 12 that we will use here. So make sure we're okay before we go to the next part of this. First, before we answer either A, B, or C, we need to establish what our XPC is so we can figure out cosine. You know what? Can I scroll up? Say again. Yeah. Right. So over here, just reestablishing what X, Y, and R are for us. So this means cosine is going to be negative 12 over 13. And sine 2 theta, or sine of 2 theta, is this 2 sine theta times cosine theta. So we plug in the values accordingly. It was given to us that sine theta is 5/13. We just figured out what cosine theta was, which is negative 12/13. And we have the 2 on the outside, so we multiply all 3 of those, that'll give us negative 120 over 169. That 2? Yes. And just multiply across, yes. Everybody good with A before we go to B? All right, so cosine of 2 theta is cosine squared theta minus sine squared theta. Plug in the values accordingly for sine and cosine. So we have negative 12 over 13 minus 5 over 13, or both of them being squared, of course. So that's 144 over 169 minus 25 over 169, do your subtraction, and that'll be 119 over 169. All right, same flow with tan. This time you want to establish what tan theta is. That's going to be your y over x. So that's 5 over negative 12. So negative 5/12. And then we plug in negative 5/12 in each place that we see tangent in the formula. So that's 2 times negative 5/12 over 1 minus negative 5/12 squared. Simplifying the top, I went ahead and canceled out the 2. And it left me with negative 5 over 6. Down with B. And then 1 minus 25 over 144. You see that I did that over there in the blue box, or dark purple box. So, you know, in order to subtract fractions, you have to have the common denominator. That's going to be 144. So 1 will turn into 144 over 144. Then you minus 25 from that. That's 119 over 144. Then we go ahead and divide by multiplying by the reciprocal. That's a negative 5, 6 times 144 over 119. You can divide 6 into 144, leave you with 24. 5 times 24 is 120. And that'd be 119 on the bottom. Any questions? Any questions? Let's scroll up. So notice here, I'm showing you another way of doing it, alternate option. So if we have sine of 2 theta, that's the same, I mean, not sine, but tan of 2 theta, same thing as sine of 2 theta over cosine 2 theta. And we just found sine 2 theta and cosine 2 theta, which is negative 120 over 169. And then cosine is 119 over 169. And then if you were to do the work, you'll still get your negative 120 over 119. So you can do either way, just that this way means that you had to find sine 2 theta and cosine 2 theta first. The other way, you wouldn't have to. Any questions? Any questions? All right, let's scroll up. Okay, next one, find the exact value of 2 tan of 15 degrees over 1 minus tan squared 15 degrees. All right, so now we're going to use the double angle relationship in reverse, because before what we had was 2 tan, and then we expanded it by using the 2 tan theta over 1 minus tan squared theta. But now we have this relationship of 2 tan theta over 1 minus tan squared theta, and we're taking it back. So theta is 15 in our case. So if you reverse the process, that means that's going to be tan times 2, tan of 2 times 15, which would be 30. And then tan of 30 is the square root of 3 over 3. All right, questions? Any questions? Mhm. So there are 3 forms of cosine 2 theta. In other words, it can be rewritten 2 more ways than what I've already exposed you to. This was the one that we talked about already, cosine squared minus sine squared theta. But then you have 2 cosine squared minus 1, and then 1 minus 2 sine squared theta. So you can use either one of those relationships when it comes to cosine of 2 theta. Mhm. So we want to verify the identity. We have cosine of 3 theta equal to 4 cosine cubed theta minus 3 cosine theta. Mhm. So first, we're going to look at that third, I said third, that's that left side, cosine of 3 theta. And notice I can use, see in the green, I can use the sum cosine of the sum of two angles. Talked about it last class, cosine of alpha plus beta is going to be cosine alpha times cosine beta minus sine alpha times sine beta. And so I can break it up into 2 theta plus theta and let 2 be alpha and let theta be beta. And plug them in accordingly. So that's what we have right here. So it's cosine 2 theta times cosine theta minus sine 2 theta times sine theta. All right. So now we just finished talking about cosine 2 theta and sine 2 theta and what they represent for us. Now, don't forget, our goal is to have all cosines. So if I can use this cosine 2 theta and break it up into a relationship that only has cosines, that would be the best move to make. And so when you go back to our options here, this second one is the one that only has cosine in it. So that's the one I chose here. And now with sine of 2 theta, we only have this as an option. So that's where we'll go. And we plug it in accordingly. So that's 2 cosine squared theta minus 1 times cosine minus 2 sine theta cosine theta times sine theta. Make sure we're okay with the substitution. All right. So we can go ahead and distribute. Let's expand this out. So the 2 cosine squared theta and the -1 being multiplied by cosine. And the same thing, well, here, oh, my eraser's still on. Sorry about that. Now here is only one term, so there's no plus or minus sign in between. So always be careful with where you're supposed to distribute and when you're not supposed to distribute. Here we have a minus sign in between our two terms, so you distribute. This is not distribution, this is just multiplication. So sine times sine is sine squared, and that's cosine there. And then here you have 2 cosine cubed minus cosine. So make sure we're okay with what happened here, going to the next step. Now we still have a sign that's involved, and we want to get rid of it because remember what we're trying to prove, that there are no, we can rewrite this with no signs at all, only cosines. So don't forget our Pythagorean identity, and that's what I have written right here. Sine squared plus cosine squared is equal to 1. Now, if I solve that for sine squared, in other words, subtract cosine squared from both sides, sine squared is equal to 1 minus cosine squared. Okay, so that comes, like I said, that goes back to your Pythagorean identities. And the one that I told you is going to always show up as sine squared plus cosine squared equal to 1. And so you can rewrite that, manipulate it, whatever way you want. In this case, it will be to our benefit to solve it for sine squared. And that'll leave us 1 minus cosine squared. And we plug that in right here in place of sine squared. So now you have -2 and cosine that needs to be multiplied to each term inside of the parentheses, and that's what I did there. So I distribute -2 and cosine. So what gives me right here, I'll have -2 cosine theta, and then cosine times cosine squared gives me, and then also the -2 gives me +2 cosine cubed theta. Make sure we're okay. All right, so now we can combine our like terms. 2 cosine cubed plus 2 cosine cubed gives me 4 cosine cubed. And then negative cosine minus 2 cosine gives me -3 cosine, which is what we're looking for. All right, questions. All right, any problems before we go to the next thing? All right. Well, let me scroll up too far if anybody's still copying. Everybody good? Okay. So now we have our power reducing formulas called power reducing formulas. Notice we start off in the first one with sine squared, and then we go down to just a cosine to the first power. Same thing with cosine squared goes down to cosine, and then tan squared goes down to cosine. So we're talking about the powers. So if you want to get rid of the fact that you have a squared trig function, you can use these three relationships. All right. Let's look at using these. So we want to write the equivalent expression for cosine to the fourth power of x that does not contain the powers of trig functions greater than 1. All right, so how we're gonna do it, we're gonna take cosine to the fourth power and break it down. So first thing we want to recognize is how we can rewrite it. So cosine to the fourth power of x is the same thing as cosine x to the fourth power, but notice how the parentheses. So make sure that you do recognize that cosine x to the fourth, is different when you use parentheses. So having those parentheses there around the whole cosine x does matter, but that's the same thing as cosine to the fourth x. So I wanted to rewrite it this way so that we can see that that's just cosine squared x squared. And so now that I have cosine squared x, I can rewrite that cosine squared x using the power reducing formula that I just introduced. And cosine squared x is 1 plus cosine 2x over 2. Any problems so far? So now we're going to distribute that power to the numerator and denominator. So that's what we have right here. We have 1 plus cosine 2x squared over 2 squared. Now, once again, just reemphasizing something we talked about, I mentioned last class. We're just dealing with algebra now. The trig element of it was the fact that we used the power reducing formula, but now we're dealing with algebra, talking about squaring, numerator, and denominator, distributing, just binomial distribution. So we have 1 plus cosine 2x times 1 plus cosine 2x. So we're going to FOIL it out. 1 times 1 is 1. Cosine 2x times 1 is 1. And then you have cosine 2x times 1 again. I said cosine 2x times 1 is 1. So let me start over. 1 times 1 is 1. 1 times cosine 2x is cosine 2x. Cosine 2x is 1 times 1 is cosine 2x. And then cosine 2x times cosine 2x is cosine 2x squared. So I'm gonna get it out. I can get it out at some point. All right. Any problems with this expansion right here before we go any further? So now we have 1 plus cosine 2x plus cosine 2x plus cosine 2x squared. All right. So notice I just rewrote this as cosine squared 2x. And then we're going to break up these fractions, and that denominator has to go into each term in the numerator. So that's all I emphasize there. We have 1/4 plus 2 cosine 2x over 4 plus cosine squared 2x over 4. Yep. Are you talking about right here? That square is over the whole quantity. Yeah. So it's just like if I had 5 plus x squared, that's the same thing as 5 plus x times 5 plus x, because it's around the whole quantity. That square is not just on the cosine. Mhm. All right. Anybody else before we go to the next piece, next part? All right. So, see what we have here next is that we need to still get rid of this power right here. And we want to end up with trig functions that do not have any power higher than 1 or any power other than 1. So these first terms over here are fine. But this one right here, we still need to work with to reduce that down. And notice our theta is 2x, so don't forget that. You do need to hold on to 2x as being our theta. So we're going to use the power reducing rule for cosine squared again. So notice I rewrote it also with the 1/4 sitting on the outside. So I can just focus on the cosine squared 2x. And make sure you don't lose a 2. And I'm gonna scroll up real quick just to make sure we emphasize what I'm talking about. Notice there's a 2 right here in front of your theta in this formula. So when I go to plug in what theta is, and maybe I should label this. This is our theta. That's why this 2 is still here. And this is theta. So that 2 comes from the formula. Any problem before we finish it off? Make sure we're okay. All right. So 2 times 2 right here, give you 4x. And then take this 1/4. And that's going to hit the 2 at bottom, make it 1/8. So that'll be 1 plus cosine of 4x over 8. I'm going to break that up again because I have this 1/4 that I can combine with this 1/8. So that 8 goes to both terms. In the green box, and just go ahead and just gave you all the work. So showing you the addition of your fractions. We have 1/4 and 1/8. Had to have common denominators. So that 1/4 is going to turn into 2/8. Multiplying top and bottom by 2. 2/8 plus 1/8 is 3/8. And this would be our final expression at 3/8 plus 1/2 cosine 2x plus 1/8 cosine 4x. All right, questions, any questions? I think this is our last set of formulas, half angle formulas. Are we okay to go to them? All right. All right, I gotta scroll up for tangent, so I'll scroll up in a second. So sine of alpha over 2 plus or minus square root of 1 minus cosine alpha over 2. And then the difference between cosine and sine, you see we have 1 plus cosine alpha over 2. And then there are 3 different ways we can do tan alpha over 2. So I'll scroll up in a second. Mhm. And there are the other two ways you can represent tan alpha over 2. Mhm. And so the plus or minus does not mean that there are two possible values for each function. It means you must determine the sign based on the quadrant alpha over 2 lies. So we know that's what we've been dealing with anyway, but that's just a statement of clarity or clarification. All right. So next one, we want to find the exact value of 112.5 degrees, the cosine of 112.5 degrees, excuse me. All right, so we're going to look at 112.5 and recognize that that's 225 over 2. Try to relate it to what we have going on up here. Gonna let 225 be alpha. So now 112.5, is greater than, it's less than 180, but it's greater than 90 degrees. So I had to put it right here, just making sure. Okay. So that means it'll be in our second quadrant. It's in between 90 degrees and 180. And so that means it's going to be negative because in the second quadrant, cosine, which is x, is negative. Your x is negative in the second quadrant. Now, 225 is one of our special angles. It's relatable to 45 degrees. If you were to use your unit circle or that special chart that I gave you, cosine of 225 is going to be negative square root of 2 over 2. That's what I wrote right here in the green. So you're going to plug that in for cosine of 225. And that's where we are right here. So that negative is sitting on the outside because cosine is negative. You have the square root of 1 plus negative square root of 2 over 2, all over 2. All right. So we need to simplify what's on the inside. I wanted to get rid of this 2 that's in that denominator and that numerator. So I multiply top and bottom by 2. That's what I did right here. So that cancels out the 2 right here. And then on bottom, 2 times 2 is 4. I wanted to simplify more because I can take the square root of 4. So I took the square root of both top and bottom. Square root of that numerator is nothing I can do with that other than converting it to a decimal. We don't want that. Then on bottom, the square root of 4 is 2. And so this is my most simplified way of expressing that exact value. Negative square root of 2 minus the square root of, hold on, let me say it right. Negative square root of the quantity of 2 minus the square root of 2 all over 2. All right, any problems, any questions, concerns, comments, anything? Anybody? All right. I think this is the last one. Yep. All right. So let's look at verifying this identity. We have tan theta. We have 1 minus cosine 2 theta over sine 2 theta on the other side of the equation. All right, so we have 1 minus cosine 2 theta over sine 2 theta, and we want to try to simplify that down to just tan theta. So, and notice there's no 2 there in front of the theta, we just want it to be tan theta. So we need to be able to break this cosine 2 theta and sine 2 theta down in such a way that it's not the application of 2 theta, but it's the application of theta. So we look at our cosine 2 theta, break that up into 1 minus 2 sine squared theta, and then sine of 2 theta, use the relationship of 2 sine theta times cosine theta. We'll just substitute that in. So that's 1 minus 2 sine 2 theta, sine squared theta, excuse me, all over 2 sine theta cosine theta. And then we have to distribute that negative sitting in front of the parentheses. So that'll be 1 minus 1 plus 2 sine squared theta. Of course, that 1 minus 1 will cancel. Leaving us with 2 sine squared theta over 2 sine theta cosine theta. Then we have sine squared over sine cosine. So that sine squared I can break up and just write sine times sine. And then what that does is enable me to cancel out one of my sines. Whether you write it out or not, that's what has to happen. You know, you have 2 sines in the numerator, one sign in your denominator. So cancel out one of those signs. That'll leave you with sine over cosine, and sine over cosine is tangent. And that's what we're looking for. Questions, any questions? Everybody good, everybody straight? Okay. So that's it for 6-3. Once again, there's no rush. So I'm not going to go ahead and push 6-5. Next class, we will get into 6-5. Look at solving these trig equations. And that's our last section out of chapter 6. So before I close out today, is everybody okay? Well, once again, some of these things may not, questions may not occur until you actually get in there and start doing some of these things. So
I'm gave for the homework fine.
say it again now.
I'm gave for the homework fine.
Okay. Okay.
I'm almost done.
All right. Sounds good. Sounds good. Good job.
Are we gonna have the test on Thursday? Are we gonna meet on that day?
What are you talking about, this Thursday?
Yes.
Oh yeah, we're still gonna meet. We're not gonna have a test on Thursday. We'll be doing section 6.5.
It's just that the homework is due on Thursday.
Well, that's not from chapter 6. Now, everything now, your first test was you do it on your own. So it's already posted in Math Lab. That should have been on chapter 5. So let me show you this real quick. Email. All right, so let's look at it. 162. So there's test 1 right there on chapter 5. Now, I haven't changed that due date. Yeah, but anyway, I'll do that in a few. But that due date is supposed to read 2/17. You know, we talked about it. You know, if not last class before last. But it's only for chapter 5's content though. So I'll go ahead and change that now. Oh yeah, I don't care what order you do it. There's nothing that's going to alert me in which order you do it. You know, I mean, if I wanted to go do research and check timelines, I could find out, but it's not that serious. So when your classmates in class asked, did it matter what order, if she wanted to knock out the test and then go back and do her homework? And I was saying it doesn't matter what order you're doing in. So it's up to you guys how you knock that out. All right. So I'll just go ahead and do this right now. Just over here. Other than that,
Just asking, I'll see you on Thursday.
all right, sounds good, sir. See you on Thursday. All right, so you guys have a good one. Be safe. And if you have any issues with due dates or whatever, shoot me that individual email. We'll make sure you're good to go. Other than that, you guys have a good one. Be safe. And I'll see you Thursday. Thank you. You have a good one as well.
Thank you very much.
And you see you Thursday.
All right, take care.
Where can I find your email at?
It's vtucker@tcc.edu.
Okay, thank you.
Yeah, no problem. No problem. Or you can always email me through Canvas. If you send me a message through Canvas, it automatically goes to that same email address.
All right.
All right. All right.
Thank
Take
you.
care. Bye.